Okay, next question is about utilization. Utilization is kind of a measurement for looking at how, what's the portion of time a machine is busy, right? So to get some ideas about utilization, I think it may be helpful to look back the tables we made for throughput time. So if you look at this table, for example, let's look at station A. If you look at station A, every 5 minutes those materials comes in, right? So time 0, time 5, time 10, time 15. So yeah, basically for each material, 5 minutes are given to work on. But if you look at this station A's cycle time is only 4 minutes. So if you look at this table, only from time 0 to 4, this machine is busy. However, there is a kind of waiting idle time from 4 to 5. And this is a kind of 1 minute of idle time. The machine is busy from 5 to 9, but again, from 9 to 10, there is 1 minute idle time. From 14 to 15, again, there is 1 minute of idle time. So you can see that every 5 minutes, a new material comes in, but this machine A is working only 4 minutes out of those 5 minutes. Similarly, if you look at station B, now there is more idle time you can find. Again, every 5 minutes, materials may come in from 4 to 9, 9 to 14, it's every 5 minutes. But this machine is working only for 2 minutes cycle time. So it will be busy from 4 to 6. But from 6 to 9, that is 3 minutes idle time every 5 minutes. For station C, again, every 5 minutes a new material is coming, but only 3 minutes this machine is busy. In other words, you can see there are 2 minutes of idle time from 9 to 11, 14 to 16, 19 to 12. But if you look at station D, actually station D is very busy. Why? Because every 5 minutes the material comes in and you have to use up all those 5 minutes. So if you look at this simulation table, indeed there is no idle time at all. By looking at this simulation table, now you may get some ideas how to calculate the utilization. Let's go back to this slide. So how to get the utilization of each station? For example, the station A, utilization in terms of time is when time is available, right? Time available compared to this time available when time machine is busy. So for station A in the previous table, what we observed, the materials are coming in every 5 minutes. Why? Arrival rate is given as 5 minutes, right? So the available time to work, to use for working on one unit is 5 minutes. So 5 minutes is available time for one unit. Does it make sense? But out of 5 minutes, only what? Cycle time, 4 minutes is used for actual work. That is utilization. Okay, so for station 8, what is the utilization? So it is a 4 over 4, and if you multiply this by 100, you will get 80% utilization for A. After you solve these questions, you can actually find some interesting relationships. What you can find here is what this 5 minutes per unit means. Yes, it's coming from arrival rate, but at the same time, this arrival rate is based on your bottleneck, right? So this 5 minute, why you allow 5 minutes? Because of this bottleneck needs at least 5 minutes. So you can say that this is a cycle time of bottleneck. Or generally speaking, it is actually cycle time of what? entire process. And then the top here, 4 minutes per unit is what? Actual time spent by this station. In other words, it is a cycle time of this specific station. So cycle time of station is on top here. So cycle time of a station divided by cycle time of process gives you what? Utilization. And then you will get 80%. Okay, so we got the utilization of A as 80%. But before we move on, I want to show you one more way to get the utilization. Do you remember when we define utilization, we consider this in two different angles, one based on time, the other based on number of units. So from that perspective, how did you get utilization? Maximum units you can produce, that is capacity. And compared to capacity, you want to know actual number of units you produce. That is utilization, right? So for station A, what's going to be utilization from this perspective? If you look at this entire process, given 1 hour, how many units you are making? Do you remember? Capacity of process. Let me review one more time. Equals capacity of bottleneck. In this case, it is D. So 12 units per hour you can make. So that is the maximum units you can make when you use this entire process. And it is called capacity of process. However, if you look at just the station A separately, given this cycle time, what was the capacity of A? Do you remember? It is 60 divided by 4. So actually you can make 15 units per hour. In other words, when you look at only station A, although you can make 15 units per hour, that is your maximum capacity. Since this is part of a whole process, the actual units you are producing is matched with the capacity of the process. So you have to produce only 12 units per hour. In this case, if you calculate it, you will get the same 80% utilizations. So in this case, it's also interesting to look at the relationship. So if you look at this formula carefully, this part is now capacity of what? 15 means yes, capacity of a station, in this case, station A. And this part is what? Capacity of entire process. So capacity of a process. So either using capacity or cycle time, you can get the utilization of each stations. Okay, so now pause the video and try to get the utilization for station B and C and D by yourself. Okay, so did you get the answer? Okay, so before I show you the answers for station B and C and D, here is one note. So station utilization, if you use capacity, on top you will use capacity of, let's see, process, but it's divided by capacity of a station. But if you use cycle time, it's reversed. On top, this must be cycle time of station. And then you divide it by cycle time of process. Keep in mind. So let's try to get the utilization for B and C and D. So for B, what's the utilization? Utilization is, if you look at cycle time, let's say 2 minutes per unit, and what's the cycle time of process? This is 5 minutes. So every 5 minutes, you can work on new units. You use only 2 minutes. That's utilization, right? So this is 40%. Okay. And for C, what's the utilization? So let's try to find C. Out of 5 minutes given, you use only 3 minutes. So what is the utilization? You will get this utilization of, let me see, 60%. And the last one is easy, right? So out of 5 minutes, you use all 5 minutes. Therefore, it is 100%. Okay, just for demonstration, let me just add one more example. So for station B, instead of this, what you can use, if you describe it in terms of capacity, you can say that, if you look at this cycle time, what is the capacity of this station B? 30 units per hour, right? But although you can make 30 units per hour based on the capacity of station B, since this is part of the whole process, you are making only 12 units per hour. So if you calculate it, you will get the same answer, 40% of utilization. Okay, so try to understand both ways how to get the utilization. Okay, so if I summarize the result here, 80%, 40%, 60%, and 100% utilization for each one. Therefore, the average station utilization is just the average of these four numbers, 60 plus 100, and then you will get 70% of the average station utilization. Okay, the last question is about cycle time, throughput time, but different assumptions. So we assume mechanically paced line. So I briefly mentioned about this mechanically paced line at the beginning. Uh, what this means is we are using a conveyor belt. You can just imagine the automobile manufacturing line where there are many robot arms and one steady speed conveyor belt line is moving. If that is the case, it's a bit different from worker paced line. In the worker paced line, when material comes in this station, either spend 4 minutes and then it can move to next station and it can spend 2 minutes. Like this, in the simulation table we made before, throughput time can be the sum of those time 4 minutes, 2 minutes, 3 and 5 minutes, and it will be 14 minutes. This is the throughput time for the worker paced line. But for this mechanically paced line, there is a conveyor belt line, and this line is moving. And this line moves at a constant speed, and we can say that there are four different sections allocated for each task. So let's say workers are standing there. And suppose materials comes in. For example, when this material comes in here, this worker will start to work on those materials. And these materials move from here to there. So during this distance, given time when material is moving from this to there, the section allocated for station A, the job must be done. Luckily, for station A, you need only 4 minutes. So let me write down 4 minutes. For station B, you need only 2 minutes. So although the length is the same from here to there, you need only 2 minutes. So as far as the material is moving from here to there, if this material stays longer than 2 minutes, this this station B is okay. For station C, actually you need 3 minutes to finish your job. So from material moving from this place to that place, at least 3 minutes must be guaranteed. For station D, this is kind of bottleneck, right? Problematic. So it means the longest time. How many minutes you need? Actually, when material moves from here to there, you need 5 minutes. But now the problem is, since all those lines, this is connected as a conveyor belt, and you have to keep moving this conveyor belt line. You cannot move this belt fast and slow like that. To constantly move this speed, you have to allocate the same time for each station, right? So how many minutes you should allow if the time allocated for each station is all same? You must look at the longest time. So since you have to allow 5 minutes at least for station D, for same distance, the movement of these materials on the conveyor belt will be same speed. Therefore, it will take again 5 minutes from this place to that place. Again, 5 minutes you will allow, 5 minutes you will allow. So therefore, if a material comes in here, these materials will stay 5 minutes here to there, 5 minutes here to there, 5 minutes here to there, 5 minutes here to there. So total through time for one material, when you trace one specific material, that should be 5 plus 5 plus 5 plus 5, or 4 of 5 minutes sections. So it's gonna be 20 minutes through time. So in this case, TP equals to 5 multiplied by 4 equals to 20 minutes. So there is difference. The red one, it is mechanically paced line. The yellow one is I'm sorry. The yellow one is worker paced line, and this red one is mechanically paced line. And we can see the difference in throughput times. Okay, that's everything for topic 2. Thank you for listening, and see you soon again.